Class, welcome to another video. I hope everyone's doing well. Today we focus on using H and K formulas as well as how to find the discriminant. Now, I'm hoping that the discriminant is a little bit of reviews. I hope that this H and K stuff is a little bit of review. However, I have a feeling that part of it might be a little new. Okay? So, before we get into the formulas themselves, we need to review. Vertex form, we know we're going to see the vertex in the equation. So this is nice. F of x equals, and then if we remember, there's an a, and then it's x minus h squared plus k. Now please note, remember, why is this negative? Because our x values, when we're working with quadratics and any graph or any equation for that matter, x is always kind of doing the opposite. So we want to say that if we have a negative h, this is actually moving to the right, which means our vertex would be at positive h, comma k. Okay? So just remember the formula that h should be negative, which means you're looking for the opposite of what you see. And then the k is exactly what you think. All right, now the axis of symmetry, we know that that's going to be a vertical line, Vux situation, so it will always be at x equals, and then whatever the h value is. All right, so in order to turn something into vertex form, we have to use what we did in the last video, which would be completing the square, or we can use H and K formulas, and we're going to state those now. This first one, I think, should be pretty familiar. H equals opposite of B all over 2A. I have a feeling you've seen that one before. This K one, I don't know if you guys have seen before. I've actually always just taught that once you get this H value to plug it in, which is acceptable. But this K formula, it's pretty nice. Okay, you can always take your C value and then subtract b squared over 4a. And so that's what we're going to do for this video. Alright, so I will leave these up for the first problem, and then we will need to start working on memorizing these. So you should probably take a little bit of time right now and try to start trying to memorize those. Alright, so example 1, find the vertex and axis of symmetry using our formulas. Cool. So here's our function. We know that to get the h value, we need to use opposite of b over 2a. I'm going to write it for a little bit so you can start to familiarize yourself with it. Negative b, if you remember a, b, c from our original equation, so we have to say we have negative 8 all over 2 times 2, or negative 8 over 4, or negative 2. So we know that our h value should be negative 2. Now the k value. C minus b squared over 4a. This is a little bit more work. We know our c value is 5. We still know our b value, so we have 8 squared. What I'm going to do is I'm going to write it as 8 times 8. And then I'm going to write 4 times 2. And the reason I'm doing this is because I am not giving you a calculator this chapter. Okay, you need to be able to do fraction work in your head or on paper. And when you keep it separated like this, it's a little bit easier to see what can cancel. For example, well, I know that, let's change colors so you guys can see my work here. I know that a 4 and an 8 become a 2 and a 1. Then what else? I know that these 2's can cancel to 1 and 1. So what am I left with, really? I'm really just left with 5 minus 8 over 1, or 5 minus 8, which is negative 3. Okay? So now I have my vertex. My vertex is at h comma k. So negative 2 comma negative 3. And my axis of symmetry is still x equals h, so x equals negative 2. And now here is the part that I need you guys to make the connection on. I need us to write our equation back in our vertex form right here. Okay, so what you have to recognize and understand, the a value stays the same from standard form to vertex form. Okay, so I know I'm going to start by writing f of x. Some of us were not doing this on tests, so please make sure that you're always writing f of x. If I ask for a function or an equation, I need to see f of x. Now my a value, again, it stays the same. A was 2, so my a value is still 2. Now it says that my h value is negative 2, so x minus negative 2 is plus 2 squared, and then of course lastly my k value is negative 3. Okay? So that is how you take your vertex and use it to write an equation into vertex form. Now let's try another one with a little bit more stuff involved that we have to take care of. Alright, so again, we look at our original equation. We know we have to get h by using negative b over 2a. Negative b over 2a. So, negative 6 over 2 times negative 3. Okay, let's see here. So negative 6 over negative 6. Okay, that's just 1. So I know my h value is 1. K, again, is a little bit more work, but we can do this. We know it's going to be c minus b squared over 4a, or 1 minus, now b squared. Okay, so 6 times 6 over 4 times negative 3. All right. Well, let's see here. Okay, I can definitely change this 3 and 6, or reduce these, I should say. So 2 and 1. How about the 6 and the 4? Can I do 2 and 3? I think so. Let's clean this up a little. I'm getting a little lost. So I have 1 minus 6 over, and be very careful, there was a negative here, so this should be negative 2 right now. Okay. And lastly, I know 6 divided by 2, or 6 divided by negative 2 is negative 3, right? So 1 plus 3 is equal to 4. Okay, so guys, you have to get really, really, really good with your fractions again, being able to reduce. The numbers should always be pretty nice in this chapter. We designed that because we were trying to do this without a calculator, so the numbers should work out pretty nice for the most part. Okay, well, now I know my vertex is at 1, 4. I haven't graphed this yet, but don't I know if my a value is negative, this is going to open down, always, right? Let's see here. Let's skip domain and range for a second. I want to have a graph. So let's go right to the writing equation in vertex form. We know f of x. Remember, the a value holds. So my a value was negative 3 originally. It's still negative 3. But then you do x minus h, so x minus 1 squared plus k. And now we could graph. We know we need to be at 1, 4. And we know our growth pattern. Instead of going 1, 1, 1, 3, 1, 5, it's going to be 1, 3, 1, 9, 1, 15 because of that vertical stretch. So, over 1 down 3, over 1 down 3, over 1 down 9, over 1 down 9, I can graph something like that. Okay, and now let's take a look at domain and range. Domain, nice and easy, right? It goes forever in both directions. That should be like that for all parabolas that open up or down. Range, well, we know we're starting at negative infinity, and then we're going up, 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 up to 4. That's our highest point, and we bracket it. Okay? Increasing, decreasing, a little bit of review. Remember, increasing and decreasing, I want the sections of graph where it's increasing. So we basically are looking for domain of each section. Domain of increasing, domain of decreasing. Okay? So increasing, we're going to be increasing on the left side of the vertex, or from here up, 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 okay, all the way until x equals 1. So we are increasing from negative infinity to 1, and then right at 1 we stop and we go down. We start to decrease, so 1 to infinity. Alright, so that was our first page of notes. Let's move on. I am going to actually no. I want to do this next example because it shows how we can use fractions and how you guys are going to have to keep things in fractions. So I think example 5 would be good to do on this video. I will find something else that maybe I can cut in a little bit. All right. So again, h. We know h is negative b over 2a. So negative 1 over 2 times 2. Okay, this is easy. Negative 1/4. Now for k, c minus b squared over 4a. So 1 minus b squared is just 1 times 1, and then over 4a, so 4 times 2. Alright, let's start to clean this up. This is 1 minus 1/8. At this point in time, I want you guys to remember you cannot add or subtract fractions unless there's a common denominator, so we're going to have to make this 8 over 8, not 1. We're going to rewrite it as 8 over 8, so now we know it's 7/8. And now we know that our vertex is at negative 1/4, comma 7/8, which is more than okay. That is absolutely fine for an answer. My axis of symmetry will be at negative 1/4, x equals negative 1/4, excuse me. I don't have the graph, but we know that because our a value is positive, this is going to open up. And lastly, remember, vertex form. So f of x, a value holds, so 2, and now it's x minus h. So x plus 1/4, that's a 4, squared, plus k, so plus 7/8. Alright, so I wanted to go through that one quickly because this shows you that you can have fractions and you guys can do it. It is okay. Now, to kind of switch gears here, we're going to talk about the discriminant. If you guys remember it, it is b squared minus 4ac. And really what I want you guys to know is it comes right from the quadratic formula. If you remember, quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, so what do we see here? The discriminant, oh, yep, we can see that now, sorry. The discriminant is coming from the square root part. It's the expression under the radical of the quadratic formula. And what it does is it tells us the number of solutions. What's another word for solutions? X-intercepts. What's another word for x-intercepts? Zeros. What's another word for zeros? Roots. Okay, so if you guys see something asking for solutions, x-intercepts, zeros, roots, what are we talking here? We're talking about finding the solutions where it crosses the y-axis, okay? And if we're talking about finding the number, then this is what you're looking for. You're looking for the discriminant. Okay, the discriminant will tell us a couple of things. So, if b squared minus 4ac is positive, right? If it's greater than 0, then it's positive. And what that tells us is that there are 2 real solutions. Okay, 2 real solutions. That means that when I plot my quadratic, it is going to cross the x-axis, I think I said y-axis earlier, I'm sorry, the x-axis at 2 spots. Alright, these are our 2 solutions. Alright, Well, what changes? If b squared minus 4ac is negative, then what's really happening is we have no real solutions. And hopefully that makes sense, guys. If this is negative, think about what happens when you plug it in. You would be taking the square root of a negative. Can we do that? No. Alright, so there are going to be no real solutions, which means our graph or our quadratic or parabola cannot touch the x-axis. Maybe something like that. Okay? No solutions. No solutions. Alright, lastly, last example here. If b squared minus 4ac is exactly 0, then you have one real solution. And again, let's think about what happens when we plug that into our quadratic formula. If we plug 0 in here, what's the square root of 0? Well, it's 0. So when you do negative b plus 0 or negative b minus 0, nothing changes. You're only going to get one value for the numerator. So that's going to look something like this. And it just, come on. It's nice and just barely touches one solution. Alright, so that's what it's going to look like if the discriminant is 0. Okay, now let's go to an example, see how this works. X squared minus 4x minus 5. Okay, we want to know how many x-intercepts this has. So what are we going to do? We're going to use b squared. Let's rewind a second. If we want to know how many, we're doing the discriminant, okay? So b squared minus 4ac, and then let's plug in. Okay, so negative 4 squared minus 4 times 1 times negative 5. Alright, all I did was I took my a, my b, and my c, and we plugged in. So this we can do. I'm going to come back up here now, though. Alright, negative 4 squared is 16. Negative 4 times negative 5 is positive 20. Plus 20. This is 36. This is positive, and that's all I really care about right now. This is positive, which means we have two real solutions. Okay, two real solutions. Now what we're going to try and do is we're going to see if we can factor it. Okay, I hope that we can factor this original problem because then I can get my solutions, right? If I want to get the solutions, then what I have to do is I have to plug in 0 for f of x, or plug in 0 for y. So that means 0 is equal to x squared minus 4x minus 5. And this I can factor. This is nice, okay? What do we got? X and x. There's only one way to get to 5, is 5 and 1. Minus plus. Alright? Because now we know that we have x-intercepts at 5, 0 and at negative 1, 0. And that is what we wanted. Okay? Part B is pretty easy, okay? Pretty easy. We want to know whether it has a max or a min. Well, really, guys, what we need to do is we need to figure out whether or not it opens up or down. And the reason is because if it opens up, then you have to have a min. If it opens down, you have to have a max. And think about that. Like if I sketched a picture, any single quadratic that I graph, or any parabola I graph, if it ever opens up, right, doesn't matter, it's always going to have a minimum. Or if I do a parabola that opens down, it's always going to have a max. Alright? So, when we look at this, my a value is positive, so I know it's opening up, which means I'm going to have a minimum. Now it says to find it. It says to find it. So what that means is we need to get the h and k values. Okay, we want to find the vertex. Let's do it. H, negative b over 2a. So negative negative 4 is, or let me write it like that, negative negative 2 over 2 times 1. Well, this is nice. This is just going to be 2 over 2 or 1. All right? Okay. We can do this. C minus b squared over 4a. So c is negative 5, so negative 5 minus b squared is negative 4 over 4a, so 4 times 1. All right? Let's think about this. We have 4's that can cancel to 1 and 1, which is nice. We have to remember that we have a bunch of negatives going on here, okay? So let's try and keep this organized. Negative 5 minus negative 4 times negative 1 is positive 4, right? So this will be 4 over 1. Or if we clean this up, negative 5 minus 4 is negative 9. So now we know that our minimum is at 1 comma negative 9. All right? Okay. Let's move on. I know we're getting a little long here. There's a lot to cover. Hopefully we will get all of this done quickly. All right? Now, to find the vertex, all right, putting all of this together, we can find a vertex, we can find some random y value, we can find zeros or x-intercepts, and we have different ways. So we know that we need h and k to get the vertex. Now you have choices, right? You have options. Of course, on this video, I want you to always use the h and k formulas, but we learned that you can either complete the square or you can use h and k formulas to get h and k. All right, so moving on past this chapter, I need you to be able to do both of these tasks. If the y is equal to some number, okay, if you're trying to find when y is some number, well then you set y, or f of x, depending on what you're writing, equal to that value, and you solve. All right, what do we mean? To solve quadratics, you need to move everything onto one side, right? You have to get 0 equals. You have to get the entire function alone, and then you're either going to factor, or we might even use some quadratic formula, okay, which we can talk about. Now, honestly, 0 root x-intercept, it's the exact same thing. It's just what? Now you're setting y, or f of x, equal to 0 and solving. All right? These are honestly the exact same thing. It's just there's a little extra work here when I give you a value, because you have to set it equal to that value, and then you have to move that over to the other side before you use the quadratic formula or factor. Okay? So for a little bit of review here, let's see here. Okay, find the vertex by completing the square. All right, so f of x, I'm going to move my c value over now, so plus 12 equals negative x squared plus 8x. Now remember, first things first, got to factor. And so I factored that. I'm also going to add a blank. All right, f of x plus 12 plus blank. Now I need to complete the square. Remember, you half and square the b value. So half of negative 8 is negative 4. Negative 4 squared is 16. So if I add 16 over here, I'm actually adding negative 16 on the other side, which means I have f of x minus 4 equals, let's see here, negative, and then the whole reason we do this is x minus 4 squared. The last thing we do is we move that back over, so f of x equals negative x minus 4 squared plus 4. All right. If we go on and actually move down, I think this might be good to do right now. Let's practice getting the h and k, or using the h and k formulas to see if we get the same exact values. So h is negative b over 2a, or negative 8 over 2 times negative 1. Perfect. 4, that's what we were looking for. And k, c minus, so negative 12 minus b squared over 4 times a, negative 1. So let's see here, boom, 2 and 1. All right, so this looks good. Negative 12 minus 16 over negative 1. Please be very careful with your positives and negatives, because negative 12, this will be plus 16, which is 4, which is what we wanted. All right. I'm going to do just a couple of other things. I'm going to skip D and E for the video just because this is already getting super long, but I want you guys to see what we can do in B and C, okay? This is an example of number 2 above in our, when I give you a y value. F of x is equal to 3, so that means I have to set my original function equal to 3. Okay, 3 equals negative x squared plus 8x minus 12. Now what I'm going to do is I'm going to move this over. I have to solve, or I have to set it equal to 0 first in order to solve. So 0 equals. All right, now one thing I would suggest doing, make this easier on yourself. Factor out a negative. Okay, keep the negative just so you understand what's going on, so you know that there's an a value still, but now we can factor this basically the exact same way. All right, that negative is now completely out of the picture. I know that this will be x and x, and let's see, 15, it's got to be 5 and 3. And then negative, negative, right? Good. So now what we can do is we can use the zero product property to tell me that f of x equals 3 at x equals 5 and x equals 3. Okay? And lastly, the zeros. Again, same type of concept. It's just now I know that my zeros are going to occur when y is equal to 0. So 0 equals negative x squared plus 8x minus 12. 0 is equal to the equation. Good. Again, I'm going to factor out that negative, so x squared minus 8x plus 12. Okay, I factor out the negative because now I can factor this real nice. What do we got? Well, x and x, 12, negative 6, negative 2. Perfect. Okay? Why do I care about this? Well, because now I know that I have intercepts, or zeros, at 6, 0 and 2, 0. All right? Let's see here. Where am I at? 29 minutes. I think this is a great place to stop. We will finish up, we might finish up the graph on this in class so that we can see and make sure that everything's good. But this is enough. I have tortured you guys enough. Hopefully you guys at this point are feeling a little more confident on your H and K formulas and using the discriminant to determine the number of solutions. Have a good day.